Today we will study lesson 2, chemical compounds. The content of the lesson: number 1, the properties of acids and bases; number 2, types of oxides; number 3, types of salts. We will start by the vocab. Number 1, acids. Acids are substances which dissociate in water, producing positive hydrogen ions, H positive. And bases are substances that dissociate in water, producing negative hydroxide ions, OH negative. Oxides are compounds resulted from the combination between oxygen and an element, even though it is metal or non-metal. Finally, salts are compounds resulted from the combination of a positive ion or a positive atomic group with a negative atomic group or a negative non-metal ion except oxygen. We will see many examples of salts to show us how combination between positive ion or positive atomic group with negative ion or negative atomic group. Here we have in our graphic organizer the classification of compounds. We can classify compounds into 4 groups: acids, bases, oxides, and salts. So compounds can be classified into acids, bases, oxides, and salts. Acids are classified according to their strength into strong acids such as sulfuric acids, H2SO4, and weak acids such as carbonic acid, H2CO3. So here we have a classification of acids. Acids are classified according to their strength into strong acids and weak acids. Strong acids such as sulfuric acids, H2SO4, weak acids such as carbonic acid, H2CO3. And we also have another classification of acids. Acids are classified according to their stability into stable acids such as sulfuric acids, H2SO4, unstable acids such as carbonic acid, H2CO3. So here in our graphic organizer there are 2 types of acids according to the classification. If we classify acids according to their strength, it will be strong and weak, and if we classify acids according to their stability, it will be stable and unstable. Oxides. As we said before, oxides are compounds resulted from combination between oxygen and element. So here we have 2 types of oxides. Oxides are classified into metal oxides and non-metal oxides. In metal oxides are formed from combination of oxygen with metals. Examples: if oxygen reacts with sodium to form sodium oxide, Na2O, it will be metal oxide. And if calcium reacts with oxygen to form calcium oxide. And here we have in these 2 examples reaction between metal and oxygen. In the first example, the metal is sodium. As you see, sodium Na reacts with oxygen to form sodium oxide. And here in the second example, calcium oxide, calcium reacts with oxygen to form calcium oxide. And here we have the third example, which is aluminum oxide. Aluminum oxide is also an example of metal oxides because aluminum is metal. If aluminum reacts with oxygen to form here the space, yes, aluminum, which is metal, reacts with oxygen, which is non-metal, to form aluminum oxide, Al2O3. So here in metal oxides we have three examples: sodium oxide, calcium oxide, and aluminum oxide. On the other hand, non-metal oxides, they are formed from combination of oxygen with non-metals. We have two examples of non-metals, which are carbon dioxide, CO2, and sulfur trioxide, SO3. In non-metal oxides, as you see in the example, resulted from reaction between carbon, which is non-metal, with oxygen, which is non-metal too, to form carbon dioxide, which is non-metal oxide. And here in the second example, resulted from reaction between sulfur, which is non-metal, with oxygen, which is non-metal, to form sulfur trioxide. So in oxides we have two types of oxides according to the type of element. If the element is metal, it will give metal oxides such as sodium oxide, calcium oxide, and aluminum oxide. And if the element is non-metal, it will give non-metal oxides such as carbon dioxide and sulfur trioxides. Please study well all these examples by writing. Now let's see salts. Salts are produced from the combination of, here in salts we have four types of salts: positive ion with negative ion, positive ion with negative atomic group, positive atomic group with negative ion, positive atomic group with negative atomic group. Here we have many examples for salts. If the reaction is between a positive ion and negative ion, it will give us salt. Will be the first type of the salt. Example: sodium chloride, NaCl. Here we have sodium atom, which gives positive ion, and chlorine atom, which gives negative ion. Then electrostatic attraction between positive ion and negative ion to give us sodium chloride or table salt. Symbol of sodium chloride is NaCl. Resulted from reaction between positive ion and negative ion, which you have studied it before in ionic bond. And we have another example, which is lead bromide. In lead bromide, lead Pb, bromide Br, and the valency of Pb divalent, so we will write 2 here below the symbol of bromide Br. Here we have an example: Pb is positive ion and Br or bromide is negative ion, and as a result of electrostatic attraction between positive ion and negative ion, it gives us a salt, which produced as a result of combination between positive ion with negative ion. The second type of salt: positive ion with negative atomic group. Example: sodium nitrate. Here in sodium, and here we have in sodium nitrate NaNO3, sodium atom Na, which gives sodium ion Na positive, and NO3, which is nitrate group, which carries negative charge. And here we have another example of salts which are produced from combination of positive ion with negative atomic group. Here we have magnesium atom Mg12, which gives positive ion Mg positive 2, and carbonate group, which carries negative charge. So here we have two examples of positive ion with negative atomic group: sodium nitrate NaNO3 and magnesium carbonate MgCO3. If salts produced from positive atomic group with negative ion, we have two examples: ammonium chloride NH4Cl. Here we have NH4Cl. We will start with NH4, which is known as ammonium group, and it carries positive charge, and the ion will be Cl or chlorine, which carries negative charge. Ammonium chloride NH4Cl, or ammonium bromide NH4, which carries positive atomic group, carries positive charge, and Br, which is negative ion. Br is a negative ion. And here we have positive atomic group with negative atomic group. You have the example of ammonium carbonate NH4, which is the positive atomic group, and CO3, which is the negative atomic group. Some mineral salts are classified into, we can classify salts according to: number 1, salts dissolved or soluble in water. So the classification will be depending on the solubility in water. If the salt is soluble in water, it will be soluble. Examples: sodium chloride NaCl, potassium sulfate K2SO4, calcium nitrate CaNO3 all by 2, sodium sulfide Na2S, magnesium carbonate MgCO3. All these salts are soluble in water. And if salts are undissolved in water or insoluble in water, such as silver chloride AgCl, lead iodide PbI2, lead sulfate PbSO4. So here we have classification of salts according to solubility in water into two groups. Some salts which are dissolved in water, such as sodium chloride, potassium sulfate, calcium nitrate, sodium sulfide, magnesium carbonate. And group B, salts which are undissolved or insoluble in water, such as silver chloride, lead iodide, and lead sulfate. Let's start our text with the properties of acids. Number 1, they have a sour taste. Number 2, they change the color of litmus paper into red due to the presence of positive hydrogen ions, H positive. And here we have to do it practically in the lab, and I prepared a video to show you how acids change litmus paper into red. It will be in the next video. The two experiments, one of them to show you how acids turn litmus paper into red, and the other will show you how bases turn litmus paper into blue. Note that chemical formula of all mineral acids begin with hydrogen joined with one of the negative atomic group except OH negative group, such as sulfuric acid H2SO4, nitric acid HNO3, or joined with one of negative non-metal ions such as chlorine Cl, bromine Br, such as hydrochloric acid or hydrobromic acid. I will read this part again. Chemical formula of all mineral acids begin with H. It means if you see any compound starts with H, it will be acid. And H joined with, you will find that hydrogen atom will be joined with number one of the negative atomic group, any atomic group except OH negative. If you find H joined atomic groups such as sulfuric acids will be H2SO4, which means sulfuric acids. And if you find that hydrogen atom joined with nitric group NO3, it will form nitric acid HNO3. But you will not find H positive joined with OH negative, because it will form H2O. It will not form an acid. 2. You will find H joined with negative non-metal ions such as chlorine HCl, hydrochloric acid, or such as bromine Br negative, hydrobromic acid. And here you can define any acids in the lab just when you look at the chemical formula. If it starts with H, it will be acids. H may be joined with atomic group except OH negative or any negative ion. It will form an acid. Now we will study the properties of bases. Their aqueous solution have a bitter taste and feel slippery. They change the color of litmus paper into blue due to the presence of negative hydroxide ion. The chemical formula of all alkalis, I mean bases, ends with OH negative. So if you find any chemical compound start with H, it will be acid, except if H is joined with OH negative, because it will be H2O. And if you find the chemical formula ends with OH negative group, it will be base or alkalis. Here we have a table comparison between acids and bases. As you see, number one, in acids, they are substances which dissociate in water producing H positive or hydrogen ions. In bases, they are substances which dissociate in water producing hydroxide ions, OH negative. And that's why it changes litmus paper into blue. Okay? Number two, the symbol of all mineral acids begins with H, hydrogen. In bases, the symbol of all alkalis ends with OH group. Number three, in acids, they have a sour taste. And you can feel the sour taste if you squeeze a piece of lemon and just taste the drops of lemon on your tongue. You will feel that what's meant by a sour taste. In bases, they have a bitter taste. In acids, they change the color of litmus paper to be red due to presence of hydrogen ions, H positive. In bases, they change the color of litmus paper to be blue due to the presence of hydroxide ions, OH negative. Examples of acids: H2SO4 and HCl. Examples of bases NaOH and examples of bases NaOH or CaOH all by 2. And here H2SO4 we will read it as sulfuric acid. HCl we will read it as hydrochloric acid. Here in bases NaOH we will read it as sodium hydroxide. CaOH all by 2 we will read it as calcium hydroxide. Please study well the comparison between acids and bases and examples of some mineral salts, because here we have in the graphic organizers classification of salts, and here how are salts formed, because it is very important to study well how are salts formed by positive ion with negative ion, positive ion with negative atomic group, positive atomic group with negative ion, positive atomic group with negative atomic group. Okay, study lesson 2 very well, and I promise you that I will prepare a video to show you how acids and bases change litmus paper into different colors and how can you differentiate between them in the lab. And I will prepare also something which will be very interesting about salts, oxides, bases and acids as a whole. Thank you.